In today's video, we're going to solve equations that either have natural logs in them or have an e in them, and we're going to use natural logs to be able to solve it. We're going to use all the same rules that we used for solving in the last 3 videos. It's just we might have a few that start with a log this time, well, natural log, but it's a type of log, or they might start in exponential form, so it will be a good review. So in example 1, we're solving natural log of x equals 3. So it's got a log in it. The natural log automatically has base e. So if we remember, any equations that start with a log, we need to condense to a single log, add, subtract, multiply, divide any extra numbers, and then we change it to exponential form. All right, so my natural log without a base written always has base e. So I've got base e to the power is 3 because that's what the log is equal to. So e to the third equals x. So to find our answer, we just have to figure out what e to the third is. So x equals, and e to the third power. Remember, e is either in the left-hand side above the natural log button, or you can use the one on the right-hand side above the divide button. If you use the one on the right-hand side, you'll have to use the caret as well. The one on the left side also already has the caret or the exponent. So e to the third is 20.09 if we want to round to the hundredths place. Doesn't matter, as long as you're not rounding to the whole number unless you absolutely have to. So 20.09 was our answer. All right, in example 2, again, we have a natural log in the problem, so we're going to change it to exponential form with base e. However, you have to be careful. If there are extra outside numbers, we need to get rid of them. So there's a 4 in the front, so 4 times natural log is what I have, so I have to divide to get rid of it. So I have the natural log of 2x equals, and I'm going to leave it as 5 over 4. We don't want to round any decimals until I get to the very end. All right, so now I have one single natural log, and and it's of 2x, so I have to change it to exponential form. So my base is e to the 5 over 4 power equals 2x. And to solve for x, we just divide by 2. So x equals, and we're going to do e to the 5/4 on our calculator and then divide by 2. So e to the 5/4 power, and I can hit enter. I don't have to divide by 2 right away. And then divide by 2, but notice I didn't retype it in. So I get 1.75. All right, so there's my answer. So I ran out of space for number 3, so let's try it here. So we got to get the natural log by itself, so I'm going to subtract 2 first. So I have the natural log of x minus 3 squared equals 3. And so we have a natural log by itself, so we change it to exponential form. My base is e for natural log. So e to the third equals x minus 3 squared. All right, now to get x by itself, I have to get rid of the squared by taking the square root of both sides. So I have x minus 3 equals, now be careful, when I take the square root, I have to take plus or minus, and then I'm going to leave it as the square root of e to the third because I don't want to round it till the very end of the problem. And then I'm going to add 3. So x is going to equal 2 separate answers, positive square root of e to the third plus 3 and negative square root of e to the third plus 3. All right, so positive square root of e to the third, and then I'm going to hit enter and then plus 3. So one of my answers is 7.48, and then I'm going to do negative square root of e to the third. And then I'm going to add 3 to that as well. So I have 7.48 and negative 1.48. So I have 2 separate answers, and if I plug them in, they'll both work. All right, so in the next three examples, if you notice, we don't have any logs or natural logs. We're all in exponential form. All right, so let's start solving these. So in exponential form, we have to try to get the base with the exponent. And I notice that all of these have base e to some exponent. We have to get it by itself. So I have to get rid of the 3 first. So divide both sides by 3. So I have e to the x equals, that's 6. And I don't know e to what power is 6, and I can't change them both to the same base. So when we did this before, we put a log in front of both sides. But instead of using a log, when I see an e, I'm going to use natural log of both sides. So I'm putting natural log of e to the x equals natural log of 6. And the reason we do that is because we use the property that says our exponent goes in front. So x times the natural log of e equals the natural log of 6. Okay, so now we have two options here. So to get x by itself, we're going to divide by natural log of e on both sides. Okay, that's one option. So we're going to get x equals whatever natural log of 6 divided by natural log of e is in the calculator. But I want to tell you that the reason I changed to natural log instead of log is because the natural log of e is 1. If we think about it, our base is e. So this is saying e to what power is e? Well, e to the first power is e. So natural log of e is 1. So it's really just like we're dividing by 1 down here. So I don't even have to divide by 1. So x equals whatever natural log of 6 is. So natural log 6, and my calculator automatically put parentheses. You might have to end a parenthesis and hit enter. And I got 1.79. I did not have to divide by natural log of e because that's 1. You can though, and you'll still get the same answer. So 1.79 is our answer. And you can, again, plug it back in and make sure it works. All right, let's try example 5. So this time in example 5, I've got e to the 2x plus 1 power. All of the 2x plus 1 is all the exponent. So I don't have anything to get rid of right away. I can actually do natural log of both sides. So natural log of e to the 2x plus 1 equals natural log of 42. And we did that so that we can take this exponent and put it in front. And when it's more than one term, I like to put it in parentheses. Okay, this is where we would divide by the natural log of e, but we just learned natural log of e is 1. So this just cancels. So I really just have 2x plus 1 equals natural log of 42. So to solve for x, I need to subtract 1. So I have 2x equals whatever the natural log of 42 is minus 1, and I'm going to wait and put that in my calculator in just a second because remember, I don't want to round too much before I get to my final answer. And be careful, this is not natural log of 41 now. It's a natural log of 42, the answer subtracted by 1, and then divide by 2. So x equals, and then in my calculator, I'm going to do the natural log of 42. I'm going to subtract 1 from it and then divide the answer by 2. Okay, so I have natural log of 42, and I'm just going to hit enter, and then I need to subtract 1 from that answer, hit enter, and then I'm going to divide by 2. So I get 1.37. If I wanted to do it all in one step, I'd have to be really careful, and I'd have to put parentheses around the natural log of 42, and it has its own parenthesis, then minus 1, end it, and then divide by 2. But that's a lot of parentheses, so I might do it piece by piece. So 1.37 was my answer. Okay, so next one, or actually our last one, example 6, has e to the x over 2 power. So that's the part I need to get by itself. So I'm going to subtract 13. So e to the x over 2 equals, that's now 2. And again, when I've got exponential form, I got to use log to solve. So instead of log, though, I'm going to use natural log because it's e. Don't forget it on the other side as well. It's got to be on both sides. Then I take my exponent and put it in front. That's my property. So x over 2 times the natural log of e equals natural log of 2. And natural log of e is just 1, so I don't need to divide by it or anything. I'm just going to cross it out. And to solve for x, I got to get rid of that dividing by 2 part. So the opposite of dividing by 2 is multiplying by 2. So x equals whatever the natural log of 2 times 2 is. Now be careful because it's not 2 times 2 is 4 and take the natural log of that. You do the natural log of 2, get that answer, and then multiply by 2. So natural log of 2, and I'm ending my parenthesis, and then times 2. Okay, now if you want, you can do the natural log of 2, get the answer, and then multiply by 2. But notice we still have the answer of 1.39.